For introduction, vitamin C is a water-soluble organic compound. It is also known as ascorbic acid or ascorbate. Its role is to protect cells from reactive oxygen species by maintaining reduced state of metal cofactor and also reducing hydrogen peroxide presence. Humans, unlike other mammals, obtain ascorbic acid through food. Therefore, the suggested requirements are around 100 mg to 120 mg a day. There were various analytical methods used to detect ascorbic acid. One of it is Hplc or high performance liquid chromatography. Hplc is favored due to its sensitivity and selectivity. It is particular in pharmaceutical and cosmetic formulations where excipients or degradations products may interfere. The study aimed to develop and validate a Hplc method for quantifying ascorbic acid in pharmaceutical preparations containing various excipients without prior sample preparation.
So as for the methodology, we need the chemicals and also reagents. So the chemicals and standard needed is vitamin C, which is ascorbic acid standard with 99% of purity. And for the mobile phase component is 1 hexanesulfonic acid, sodium salt, acetic acid, and also the ionized water. And lastly, we need the Hplc grade solvents, which can be methanol and also water. So as for the equipment needed is first we need Hplc system with a DAT, which is diode array detector. And the second one we need surface sphere RP18 column, which can be 250mm times 4.6mm as for 10 micrometer particle size. The third one we need is centrifuge and membrane filters, which is 0.45 micrometer. And lastly, we need the analytical balance. As for the experimental design, first we need to prepare the standards. To prepare the standards, we have to prepare a stock solution of ascorbic acid 1 mg per ml for the concentration by dissolving 50 mg of mixture of water and acetic acid with the ratio 21 volume over volume. And then we need to dilute the stock solution to working concentration of 0.2 till 1.5 mg per ml for calibration. And the second one we need is for the sample preparation. We need to weigh approximately 250 mg of each pharmaceutical formulation, for example, tablets and also powders. Lastly, we need to dissolve in 50 ml of the mobile phase, centrifuge 3000 rpm for 5 minutes and filter the supernatant through a 0.5 micrometer membrane. So these are the simplified Hplc conditions. As you can see, the mobile phase is prepared by dissolving 1.5 gram of 1 hexanesulfonic acid, sodium and salt in 500 ml of acetic acid and mixing it thoroughly. And the final pH of the solution is adjusted to 2.6. Okay, for the Hplc column and setup, we use a supersphere R18 column for the separation process and to maintain a column at a constant temperature of 20 degrees Celsius to ensure the stability of the ascorbic acid. As for the separation procedure, we have to operate the Hplc system under the isocratic conditions. Firstly, we have to set the mobile phase flow rate to 0.7 ml per minute. And the third one is inject 50 microliter of the prepared sample solution into the column. And lastly, we have to ensure each run lasts not longer than 4 minutes for the optimal resolution. For the detection, we have to use a UV detector and set a wavelength of 280 nanometer to monitor the effluent. And to confirm the retention time for ascorbic acid is around 4 minutes.
This is our simplified Hplc data that we got from this analysis. So if you look at 40 mg per G concentration, the average recovery was 102.39%, indicating slightly above target recovery, which is acceptable for accurate quantities. For 50 mg per G concentrations, the average recovery was 101.70%, still close to the target of 100%, and showing a good reliability. And also for 60 mg per G concentrations, the average recovery was 100.07%, almost perfect and well within acceptable limits. And so for the precision RSD, the RSD value was extremely low across all concentrations, which is at 40 concentrations, we have the RSD value is 0.048%, and for 50 mg per g concentration, we have 0.442%, and for 60 mg per g concentration, we have 0.020%. So this low RSD value shows that the method is highly reproducible and precise with minimal variability between all the measurements. Next, we look forward into the linearity testing. So the graph below shows that the linearity of ascorbic acid in Hplc analysis. The x-axis represent the concentration and the y-axis represent as the corresponding Hplc peak area. The linear relationship between the concentration and the peak area is evident from the straight lines, confirming the good fit indicated by the regression equation and the high correlation coefficients, which is R squared equal to 0.9998. The regression equation for the Hplc analysis of ascorbic acid is y equal to 10245x minus with 89.95.
Hi, my name is Nur Dewi Hanani. Next, the limits of detection LOD and quantitation LOQ are key metrics in analytical methods. LOD is the lowest concentration of a substance that can be detected, while LOQ is the lowest concentration that can be quantified with acceptable precision and accuracy. For this method, LOD is approximately 1.95 nanogram per milliliter and LOQ is about 6.5 nanogram per milliliter. This value was determined using signal-to-noise ratios of 3:1 and 10:1 respectively. Next, the Hplc method shows high specificity with no interference from excipients or antibiotics. Ascorbic acid is well separated from other components and degradation products, confirming the method's effectiveness for vitamin C analysis. Next, as you can see the figures 1 and figures 2, consistent chromatograms showcasing identical rotation times for both standard and test sample reinforce the reliability of the developed method. The results in the table demonstrate the accuracy of ascorbic acid determination in the products indicated by the RSD. The preparations are Betadox, Burfax, Efferogan, CHC vitamin. The label content for Betadox is 50 mg. The actual contents plus minus SD for Betadox is 49.52 plus minus 0.93. The RSD is 1.87. Next, Burfax. The label content for it is 200 mg. The actual content for it is 190.05 plus minus 3.32. The RSD is 1.36%. Further, Efferogan. The label content for it is 200 mg. The actual content is 192.78 plus minus 1.46. The RSD is 1.46%. Last but not least is CHC vitamin. The label content for it is 200 mg. The actual content is 207.73 plus minus 1.02. The RSD is 0.42%. Together, these aspects illustrate the method's efficiency for accurate and reliable vitamin C quantification in pharmaceutical formulation.
So the discussion for this analysis, the Hplc method developed for determining ascorbic acid in pharmaceutical formulations proved to be efficient and reliable. It demonstrated a short retention times, ensuring accurate detections of vitamin C without interference from doxycycline or other excipients. The method showed excellent linearity in the concentration range of 0.25 until 1.5 mg per ml, indicating consistent performance. The precision of the method was confirmed by low RSD value, and its sensitivity was highlighted by low LOD and LOQ values. Furthermore, the methods effectively separated ascorbic acid from potential degradation product, proving its selectivity. Overall, this Hplc method is precise, sensitive, and selective, making it suitable for analyzing vitamin C in pharmaceutical preparations.
Our finding demonstrate that the developed Hplc method has been successfully validated for linearity, accuracy, recovery, and precision. It also exhibits low value for limits of detection and quantitation, making it highly effective for determining ascorbic acid. This method is capable of analyzing pharmaceutical preparation containing a variety of excipients, such as doxycycline hydrochloride, phenyramine, paracetamol, and others. What sets this method apart is its speed, sensitivity, accuracy, and reproducibility. Additionally, it does not require prior sample preparation, which makes it ideal for the rapid analysis of vitamin C in pharmaceutical and veterinary formulation. In conclusion, this validated Hplc method represents a significant advancement in pharmaceutical analysis, providing a reliable and efficient tool for quality control.